All right, we got the Pythagorean theorems today. I would say the most popular theorem of all time. All right, you've probably even heard of it before, even if you've never been taught it. Yes.
Can you say it a little slower?
Pythagorean. Pythagorean. Repita, por favor. Pythagorean. 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 It comes from the mathematician. You're going to see where I'm going with this in just a minute. I wish I could do this. It comes from the mathematician Pythagoras. It was Pythagoras. It's the Pythagorean theorem. And his teaching style was that for the first, I think it was 3 years, any of his students that he taught were not allowed to talk for 3 years. It was called the Pythagorean silence. He did not allow his students to talk.
I would have broke that rule.
So freshman, sophomore, junior year, no talking.
I would have broke that rule.
No questions. You just listen.
No.
Follow along. All right. A squared plus b squared. Pythagorean silence, please. Thank you. This is only for right triangles. Do you agree? Have you seen this before?
No.
Have you ever heard of it?
Nope.
Everyone had to have heard of it.
Nope. How have you not heard of that? Chris, what are you talking about? Under a rock? Yes, I did.
Right?
What if you're like doing really bad and you have a question?
You're not allowed to ask.
So then you're gonna fail.
I would I'd still ask.
But then he would give you an answer.
So I just stare at him.
All right.
I'd probably get beat.
Now, A and B. Do you guys remember the names of the sides of the triangle? We have legs and we have hypotenuse. Right? We've heard of that. A is a leg, B is a leg. Now, could they be called X and Y or N? And that? Yeah. But whatever is across from the 90, in this case it's C, is called the hypotenuse. You have to keep the hypotenuse straight. So, for you and you alone, I have created a quick, easy way, even if the triangle is turned, to identify the hypotenuse. Are you ready? If you draw the right angle symbol, it's almost like it creates an arrow pointing across to the hypotenuse. Okay? Now, most of you don't need that, but some of you do. That is the hypotenuse. You have to keep the hypotenuse straight. Now, I know what you're thinking. Isn't the hypotenuse the longest side? Yes. Sometimes it's not really obvious, though. All right? And so you kind of want to think it's across from the 90. It's not the two sides that touch the 90. It's the opposite side. Here we go. Our first Pythagorean theorem. Now, how and why? Well, we're going to set it up. A squared plus b squared equals c squared. And it's going to solve for a missing side in a right triangle. Are we solving for the hypotenuse here or one of the legs? Very good. So where does the hypotenuse have to go in my equation? On its own side of the equal sign. It's so lonely over there. Some of you guys can relate. All right. 2 squared plus 6 squared equals x squared. Could I have put 6 squared plus 2 squared? Yes, because addition is commutative. Commutative. Now you're gonna want your calculator out right now. I'm gonna show you some things that apparently, according to second period, will blow your mind.
Are you recording this video? I feel bad after asking what hears me.
Feel bad what?
Whoever watches this hears me. I feel bad for
I feel bad for people in here every day to have this video.
But like you would be watching this, and that's sad. You would hear me say, "Oh, come to beat." Yeah. You're gonna hear that.
I think she's talking right now just so people.
Well, I'm not.
Do you agree? All right, listen carefully. In the calculator, how many of you would type in 2 squared and hit enter and oh, it's 4? and they would type in 6 squared and get 36 and 6 squared is 36. And get enter and hit 36 and then 4 plus 36. Okay. You're gonna see a pattern here. Let's just type in, ready? 2 squared plus 6 squared and then hit enter. All right, did you get 40? So 40 equals x squared. Now, before you type in anything else, I'm going to try to show you guys a shortcut. Right? Shortcut. Especially when we get big numbers with decimals later. This is going to be nice. Does everyone's calculator still say 40?
Mm-hmm.
Okay. We have to hit center. No, that's not the word I'm looking for. No. Second x squared, right? To get the square root. Yes? So without hitting clear, without hitting enter, anything, keep the 40 there, and then second to get this x squared to get the square root. Everybody have that? So you should have square root. And then second negative will insert the previous answer of 40 into the square root. Do you agree? Hit enter. Did you get 6.32? So what did that do? That took the square root of our previous answer, which is what we wanted here because we had to square root both sides. No, that's not it.
What I originally did is I just radicalized everything.
I haven't changed.
All right, real quick. Hey guys, listen. We need to get through this quickly. Come on. The second negative, what did that do? Well, if you look above the negative button, do you see the little blue ANS there? See the negative button? Okay, some of yours it's white. Most of yours it's either blue or yellow. I don't know. It's the little letters. They're actually on the actual plastic of the calculator. See in there? You hit second to get them. Now, that answer button is going to be really helpful later on in math, okay? So that's why I'm showing you today. So what happened here? All eyes up here. You did 2 squared plus 6 squared. And because the unknown is over here, you had to square root both sides. So x is the square root of 40. Now, if I could write a decimal, I would put 6.32. Thank you. 6.32. Are you with me? If I was allowed to put a decimal. But look at the directions. Uh-oh. Give your answer in simplest radical form. So that second answer thing didn't help us for this problem. Okay? So why? I can read your mind. And it's full of complaints. Okay? But why would I do that then? Good question. Only I said it nicer than what you were thinking. Okay? What do we know about the hypotenuse? It is the longest side. Isn't it good to check to make sure our answer, 6.32, is longer than 6 and 2? It's helpful to know, right? Now, we're going to write it in simplest radical form. Remember doing this? What would you guys do for 40? 2 and 20. And then 20 is 2 and 10. What's 2 times 2? What's 2 times 2 times 10? 2 times 2 times 10. It's still 40. We're still good, right? Pair of 2s, what comes out? 2. And a 5 and a 2. I could break it down in 5 and 2, but there's no pairs. And so it's 2. And I didn't want to do that. 2 comes out. The 10 is still inside the square root. 2 radical 10. X equals 2 times the square root of 10. Now, what happens if you type in 2 times the square root of 10 in your calculator? You get the same decimal as when we did that fancy voodoo calculator work, right? 6.32. So this would be the answer I would put for this problem because they asked for simplest radical form. Are you with me? Pythagorean theorem. Let's do the next one. What's the first thing you should do every time you do a Pythagorean theorem problem? Locate the hypotenuse. Which one's the hypotenuse here? 20. So x squared plus 14 squared equals 20 squared. Do you see the difference? I'm not adding them and square rooting them this time, am I? Thank you. I'm not adding and square rooting this time, am I? Are you making fun of me? That's the second time today. You mocked me. You don't have this to students that mock me.
I know.
I'll remember that. All right, here we go. So what should I do to solve for x this time? Now, I do want you to show your work. But in the calculator, aren't I doing, ready? 20 squared minus 14 squared, and then square rooting that answer, aren't I? If you want to write it out, x squared plus, I think 14 squared is 196, is that right? $15 squared is 225, 16 squared is 256, yeah, 196.
Yeah.
Now you guys got me second guessing myself. Yep. All right, so 400 minus 196 is 204. Square root both sides. And let's see how they want us to write our answer. Simplest radical form. 's factors. Or is it prime?
Prime.
Who votes prime? Danny.
3 and 17.
Boom. 3 and 17. But 3 and 17 won't give us any pairs. Robin.
Well, there's 4 and 51.
This is 4 times 51. We'll get us the original number. But we're trying to break 51 down.
Oh.
So that would be 3 and 17. No pairs. Okay. No partners. Some of you can relate. So we have no pairs out of 51, but 2 and 2 make 2 radical 51. What's something we should check maybe in our calculator? Is 2 radical 51 as a decimal? Where's x? Where's x? Is it the hypotenuse or is it a leg? It's a leg. So should it be less than 20? Yeah, 20 is the hypotenuse. 14.28 is less than that side. Do you see how to kind of check these? Get a ballpark. Pythagorean theorem. Aren't they kind of fun? They're kind of fun. All right, now we got a real life modeling problem. real life modeling problems.
Why do you look at me when you like
Where can we go to my section? Some obstructions.
Did you guys solve it yet? Solve it. Gotta read the problem. Let's go. Let's go.
Everyone does. No.
Did everyone get that set up? The support beam is the hypotenuse, correct? Excellent.
No, because I came right from a boarding school.
No problem. All right, here's what I would recommend on this one. This is where we want to use that calculator trick we learned earlier. Not really a trick, just process. Do you agree? We're gonna look at the answer. Round to the nearest hundred. Round. Okay? Some of you can relate. Some of you are not very well rounded. All right, so when we go to type this in, hey, when you pick on me, I will roast you the rest of the class.
I know. But it's funny. It's my favorite.
All right, all joking aside, watch up here real quick. Do you remember a couple days ago when I said there is going to be a time soon where if you round an answer and then you have to do another calculation and round it again, it's going to compound rounding error, yes?
Yeah.
This is that time. Because what happens if you square, this is not what I want you to do, 23.26 squared, 541.0276. And what's going to happen? You're going to round it to nearest 100, nearest 10. And then you're going to add it to this rounded number. Round again. And then you're going to have to square root both sides. Round again. You see where I'm going with this. You're going to keep rounding and rounding. And you wouldn't want us to do that to your grade. Think about it. What if at the end of the 9 weeks, you have an 89.9%? You know what the school does? 89.9%. Do you know what they do? 89. Truncate. If I were you, I would protest. Okay. Then what? Second 9 weeks. Truncate. Average those. Semester average plus the net exam. I wouldn't want that to happen to my grade, would you? Sounds like some protesting is in order here. Seriously, why? Like, why truncate? Can't we round? Shouldn't we round? I mean, we're a democratic society. Where'd those decimals go? Who's taking all those decimals? Who's taking all those? 89.9 goes to an 89. What happened to the 0.9? Where's it going to go? Some poor people out in the cold. All right. Here we go. What am I trying to say here? I really don't know anymore. All right. But here's what we're going to do. Everybody with me. In synchrony. 23.26 squared plus 47.57 squared. I'm going to say it again. 23.26 squared plus 47.5 squared. I have not hit enter until I have typed in this whole thing right here. Are you all ready to hit enter together? 3, 2, 1, push. That actually was pretty good, class. That was pretty good. Morgan was a little bit off, but it's okay. All right. Peyton was like 10-second delay.
No, I didn't.
Does everyone have a number that starts with 2803.9325?
Yes.
Awesome. In all honesty, the decimal may keep going on. I don't know. It's okay though. We're not going to round. We're not going to round because that number, it earned those place values. We're going to let it have all of them. All right, here we go. Ready? But what are we going to do with this number? We're going to square root that whole number, aren't we? Ready? Second x squared to get the square root. Second negative to get the answer inside the square root. We're going to hit enter on 3, 2, 1, push. Did you get x is 52.95 17182. Yes? Then I look at the answer and I say, okay, round to the nearest hundredth. There you are, hundredth. I'm going to look at the thousands to round. X equals 52.95 meters. 52.95 meters. Did you get that? Did you use the little trick in the calculator?
Yeah.
Isn't it life-changing?
Absolutely.
Free.
Would you click?
I'll show you here in just a minute. Next, I got one for you to try. Ooh, I don't want to give that away. Close your eyes.
No.
I said close your eyes. I thought teaching would be different. I thought students would listen.
Oh, you got. I know who said.
So 23.26. And okay, so this is the whole side of the left. This is the whole left side. We have to square root both sides. So now hit square root second x squared, and then we want to put in that previous answer to second. So that would take the square root of our previous answer. So we don't have to type it all in again.
Okay.
Does that make sense?
Yeah.
So like I think the
Like basically, what are we solving? Like, because I wasn't in here.
We're solving for a missing side in the right triangle. So here it was the hypotenuse, here it was a leg, here is the hypotenuse, here it's a leg. Whatever the hypotenuse is, it has to go on that side of the equal sign. Okay?
And then if it just
All right, did everyone get this set up? Now, sometimes you're going to square the numbers and add them. Sometimes you're going to square the numbers and subtract them. Some new TikTok or what?
No, we got sanitizer.
Is that? I don't know what that is. Material girl. All right, two options. One, you can solve it the old-fashioned way. X squared plus 225 equals 189. Nope. 289. Hey guys, listen. Option one, type in the numbers and hit enter and get the numbers and calculate them the old-fashioned way. Subtract 225 from both sides. What's 289 minus 225? And when you square root both sides, you get x equals 8. Option 2, in the calculator, you type in 17 squared minus 15 squared, and then square root that answer, right? Do you agree? All right. Now, it's said to give our answer in simplest radical form. What is that answer in simplest radical form? It's 8. It's 8. Okay. The square root of 64. We never really did. I don't know if your teacher ever really taught you this way, but do you agree the square root of 64, if you broke it down, is 8 and 8? Oh, look, a pair of 8s. What gets to come out? An 8. Radical. Nothing. There's a 1 there. Okay. Nothing would be like someone's friends on the weekend, right? Nothing would be like. I mean, sorry, hit a little too close to home. Okay. There's actually a 1 in there. Now, what I want you to write 8 radical 1. It depends whose quiz it is. But no, 8 radical 1. Radical 1 is just 1. Just write 8. Just write 8. X equals 8. So the sides of this triangle are 8, 15, and 17. Oh, look. Those are all whole numbers. That's kind of unique so far because every other one we've written in simplest radical form, like 2 radical 10. Was 2 radical 10 a whole number? Was 2 radical 10 a whole number? Was 2 radical 10 a whole number? Type it in.
No. Yes, kind of. I don't know.
What's a whole number?
But just one thing. No decimals.
Wait a minute. Hold on. Let's back up. Do you know what a whole number is?
No.
Not a decimal.
Yeah, that's what I thought. I
Yeah.
said that.
Like 5 is a whole number. 5.1 is not a whole number. So is 8 a whole number? Yes. Is 2 radical 10 a whole number? No. So if one of the sides is 2 radical 10, then not all the sides are whole numbers. If it's 8, 15, 17, yeah, those are all whole numbers. There's a special name for that. Special name for that. Okay? It's called a Pythagorean triple. Pythagorean triple. Okay? A set of 3 non-zero whole numbers, a, b, and c, such that a squared plus b squared equals c squared is called a Pythagorean triple. I heard McDonald's is considering a new burger with 3 patties, all right triangles,
What?
called the Pythagorean triple.
No.
I just heard.
Yes, great. Please go.
American cheese would be cut diagonally so that they're all right triangles to fit right on it.
Are you okay?
No.
You wonder if I'm okay.
If you want a psychological experiment of what happens to an individual when they teach teenagers for 17 years,
I forgot this.
5 classes a day,
17 years? I forgot this is still recording.
17, longer than you guys have been alive. Yes.
So why is McDonald's the one making the triangle? Their patties are typically rounded.
Ooh, Wendy's would make more sense.
Yeah.
Because they have a
Yeah,
square.
that's square.
I'll change it for next time I teach you. Grace. I don't know.
I know.
I'm really
Oh, I thought this was a joke.
No, I don't know.
What'd you ask?
Yeah, but like, oh,
What'd you ask?
All right, here we go. Something else that may blow your mind.
what?
All right. Let's say we want to make a triangle. Give me some sides to make a triangle. Like, give me like in feet. Let's talk about like, let's build something and make a triangle. Give me some sides. Give me one of them.
52.
52.
That's how I say it.
33. One. Silas.
13.
Silas. Oh, Silas.
48.
Question.
That's not a triangle.
You're saying it's not a triangle?
It's
It's not connected.
It's smaller.
It's not shaped.
So can 1, 3, and 52 be side lengths of a triangle? No, it does not depend on how you do it. How could you put those together to make a triangle? It's not dance time. It's not time for TikToks. Not like
Make the left side, the left hand angle.
it's gonna
Why
triangle.
don't you switch 52?
Oh, I'm just putting on some Purell.
Something.
Now I'm making triangles. I taught him that geometry is gonna start catching on. Go ahead, Ella. Sorry, I didn't mean to interrupt you.
Oh, I was just saying that you make the angle on the left smaller. So then it like that side could connect.
Okay,
to one.
so let's make believe. Okay, let's have a little time of make believe. Let's pretend this right here can pivot. Do you know what pivot means? All right. So this side, ready? Ella wants to pivot it down, right, Ella?
Right.
Now Silas's little guy over here, this 1 foot side, is also going to pivot.
Never mind. I take it back. Son, you
I call it T-Rex syndrome. Okay. It's like
Your whole body have that.
trying. It's trying so hard. Trying to touch. Just can't. 2 arms are too small. Do you guys understand? So you might have walked in today thinking any 3 side lengths can make a triangle. False. I don't know why you guys are packing up. You got four solid minutes here. 4 solid minutes. So question for you. Hey guys, I need you to listen. Why didn't 133 and 52 make a triangle? What about them did not make a triangle? They don't connect. Why? What would he need to change his 1 to make a triangle? Cool.
Another 33.
That would work, but what's the smallest? Andrew, do you have an idea?
I was going to say a number between 32 and 52.
What about 20? Would 20 work? We'll talk about that on Monday. I want you to think about this. Carissa,
Could you like square those and then do x squared and then you find
we don't need to get into the Pythagorean theorem yet. I'll give you a hint. Ready?
Thank you. Because then they equal
All right. Wait, hold up. Before you pack up, listen. These are some examples of Pythagorean triples. If sides were 3, 4, hypotenuse would be 5. 5, 12, hypotenuse would be 13. These are nice whole numbers that fulfill the Pythagorean theorem. All right? So our assignment for tonight / Monday morning before school, all right, this is only half of the lesson, by the way. All right, we'll do the second half on Monday. I broke it up into 2 homework assignments. This is for the weekend.
and watch the video when they see.
Yeah.